For our third example here, we want to show that the product law can't be applied to a limit as x approaches 0 of f of x times g of x if f of x equals x and g of x equals x to the negative 1. If you kind of look back up in the notes a bit, you'll remember that the first thing that we have to do to apply these laws is we need to kind of check and make sure that both the limits exist. So the limit as, well, we'll say it this way. If both the limits existed, then we could use the product law, and this part right here would equal the limit as x approaches 0 of f of x times the limit as x approaches 0 of g of x. Limit as f of x is just x, so this would be limit as x approaches 0 of x, and this right here would be the limit as x approaches 0. X to the negative 1 is 1 over x, which when you put a 0 in here, 1 over x's graph looks like this. When we try to say what's the two-sided limit at 0, well, as you approach for the left, the graph approaches negative infinity. As you approach from the right, you approach positive infinity. So this limit right here does not exist. So you can't actually apply, the product law as limit as x approaches 0 of g of x does not exist. The problem is there's a vertical asymptote in the graph. One side goes to negative infinity, the other side goes to positive infinity. And even if they both went to positive infinity, we want to remember that we said infinity is not a true limit. It kind of gives a description, but it's not actually a number. So we would still have problems trying to apply the product law if this here was still trailing off towards infinity. So that's all we need to do to show that you can't apply the product law for that one.